Okay, let's talk about rational functions. All right, so for each of these in this first part, we need to find all the pieces. Find the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptote. One word of warning. You want to factor and simplify first, because you may have common factors to the numerator and denominator, and all of this only applies to the simplified form. Okay, so to find the y-intercept, you find f of 0. Once it's simplified, to find the x-intercepts, you set the numerator equal to 0. To find the vertical asymptotes, you set the denominator equal to 0. And then the horizontal asymptotes you have to compare n and m, the degrees. Okay, so that's just it in a nutshell, just a real brief thing to tell you what you're actually supposed to do. Okay, so let's start off with number 1. All right, neither of these can be factored, so it's in its simplified form. So to find the y-intercept, you find f of 0, which is 2 times 0 plus 1 over 3 times 0 minus 1, which is 1 over negative 1, which is negative 1. And you want to write that as an ordered pair, so the y-intercept is 0, negative 1. Okay, for the x-intercept, okay, 0 divided by anything is 0, so if you set the numerator equal to 0, then you're done. So 2x plus 1 is 0, 2x equals negative 1, so x equals negative 1/2. So my x-intercept is negative 1/2, 0. Okay, to find the vertical asymptote, that is where it's undefined, which is where the denominator is equal to 0. So the vertical asymptote, we set 3x minus 1 equal to 0, 3x equals 1, and x equals 1/3. This is a vertical line, so it's x equals 1/3. And then lastly, the horizontal asymptote, we have to compare the n and m. So for the horizontal asymptote, n is 1, m is 1. They're the same. So if I look at 2x plus 1 over 3x minus 1, my vertical asymptote is just this. Everything else, as you get close to infinity, has no consequence. So my horizontal asymptote, and it's a horizontal line, so it's y equals 2/3. Okay, so for r of x, well, this can be simplified. This is r of x is equal to x plus 3 divided by x plus 3 times x minus 3. This cancels out, so what I'm looking at is 1 over x minus 3. Now, this is what I'm looking at to find all of this information. But what this tells me is there is a hole at x equals negative 3. So it's undefined there as well, but it's a hole. It's not an asymptote, it's just a hole in the graph. Okay, so for my y-intercept, I set find r of 0, which is 1 over 0 minus 3, which is negative 1/3. So my y-intercept is 0, negative 1/3. Okay. My x-intercept, I set my numerator equal to 0. That's not possible, so there is none. Okay. For my vertical asymptote, I set the denominator equal to 0, x minus 3 equals 0, so x equals 3. And again, it's an equation, x equals 3. And lastly, for my horizontal asymptote, I compare the degrees. N is 0, m is 1. Since n is less than m, the horizontal asymptote is y equals 0. Okay, let's do a few more of these. Alrighty, so if I have h of x equals x squared minus 6x plus 9, x squared over x squared plus 2x minus 15, this becomes x minus 3 times x minus 3 divided by x minus 3 and x plus 5. Okay, so I have a common factor of x minus 3, so there is a whole at x equals 3. So that doesn't, oh, I'm so sorry. That doesn't impact any of the stuff that we're doing. But I'm only going to be looking at this for the rest of my information. Okay, so for my y-intercept, I find h of 0, which is 0 minus 3 over 0 plus 5, which is negative 3/5. So 0, negative 3/5. And again, write it as an ordered pair. For my x-intercept, I let my numerator equal to 0, so x minus 3 equals 0, so x equals 3. So my y-intercept is 3, 0. Okay, so my vertical asymptote, I have x plus 5 equals 0, so x equals negative 5. And again, it is an equation of a vertical line. And then lastly, for my horizontal asymptote, I look at my degrees. The degree of my numerator is 1, the degree of my denominator is 1. So if I look at x minus 3 over x plus 5, that's a plus. The only thing I look at is the coefficients of my x terms. Everything else falls to the wayside. So my horizontal asymptote, a horizontal line, is y equals 1. Okay, so for number 4, it's already in factored form for me. So we can start out by finding our y-intercept. We find f of 0, which is 1 over 0 minus 4, 2 times 0 plus 3, squared, which is 1 over negative 4 times 3 squared, which is 1 over 9 times negative 4 is negative 36. So it's 0, negative 1 over 36. Okay, then my x-intercept is when my numerator equals 0, which is not possible. So there's none. Okay, so my vertical asymptotes, all right, I set my denominator equal to 0. So x minus 4, 2x plus 3 squared equals 0. So that tells me that x minus 4 equals 0, so x equals 4. 2x plus 3 equals 0. 2x equals negative 3, so x equals negative 3 halves. Okay, and so again, these are vertical lines. So x equals 4 and x equals negative 3 halves are my vertical asymptotes. And then finally for my horizontal asymptotes, well, the degree of my numerator is 0. The degree of my denominator is 3. Since n is less than m, it defaults to y equals 0. Okay, so we're going to use transformations now to sketch the graph of this. All right, and graph and label any horizontal or vertical asymptote. Okay, here's what I'm always going to do. I'm going to start out with my parent function. So the parent is y equals 1 over x squared. And I'm going to briefly sketch that. And I always like to do it in pencil so it doesn't get too messed up. All right, so I know that the parent function looks like this. And I know that Alex wants you to be much more specific. I don't think we need to. Okay, so here's what we have to think about is what are our transformations? So and remember, what I'm going to transform here are my asymptotes. So I have a vertical asymptote at x equals 0 and at y equals 0. So my vertical asymptote and my horizontal asymptote. So I'm going to, if I am shifting this up or down, left or right, is going to change my vertical asymptotes. Okay, so let's see. What am I going to do here? Well, I'm going to shift to the left or to the right first. So I am going to shift right 5 units. Then I have a vertical reflection, which is across the x-axis. And then I'm going to shift up 1. Okay, so I'm going to start by, if I shift to the right 5, then what that does is that moves my asymptote over here to 5. So for my new graph, my vertical asymptote is going to be fine. Shifting up 1 means that my asymptote is going to go here. And then I know from the general shape of my graph that if I move it all the way over here and then reflect it, then I've got a point here, and I've got a point here. And there's your new graph. Okay, so for my new graph, I have a vertical asymptote at x equals 5 and a horizontal asymptote at y equals 1. Of course, this goes with this, and this goes with this. Okay, my parent function on this one, my parent is y equals 1 over x. And we know what that looks like. I know my asymptotes are at the origin, and that's the general shape of my graph. So what kind of transformations am I doing to that? The plus 3 means I'm going to shift left 3, and then I'm going to shift down 2. Okay, so what that does is that moves my asymptote. So shifting to the left 3 gives me a vertical asymptote of x equals negative 3. Shifting down 2 means I have a horizontal asymptote at y equals 2. So I'm going to draw those in, and then I know how to graph that. Okay, so x equals negative 3. Y equals 2. And then I've not done any stretch, shrink, reflection, anything. I just move these points up here. So this becomes a point here, and this becomes a point here. And I have my graph. Okie dokie. Let's see. I think this is probably a good place to stop for a minute.